Hi, now I'm gonna show how to analyze the simple bit register using the CML model checker. First, I'm going to create a new project and now I'm going to import a new bit register file which is already implemented. This is the simple bit register. It has a warning here because the state variable has not been initialized. So we just put the initial value here and the warning disappeared. The model has values, functions, channels, and processes. In the values sections, we define a maximum value which is useful to detect overflows. Concerning functions, we have the overflow and the underflow functions. And channels, we have untyped channels and typed channels. The bit register process itself defines a state variable and operations and actions. Concerning operations, we have init, which just initializes the reg variable, the add operation, which increases the reg variable, and the sub operation that decreases the reg variable. Concerning actions, we basically have an auxiliary action reg and the main behavior of the process. The main behavior just performs init and calls the init operation to initialize the state variable and behaves like reg. The reg action is a choice between two behaviors. The first behavior offers increment event, increment by 1, and if this does not cause overflow, the behavior calls the add operation and behaves like reg again. The other behavior offers the decrement event decrement by 1, and if this does not cause underflow, it decreases the value of the reg variable by 1 and behaves like reg again. Looking at the init operation, it is easy to see the initial value for the reg variable, in this case 7. The overflow function is called using the parameters reg and 1. This means that it returns false only if reg is 8 because j is 1. Furthermore, the real increment on the state variable only happens when the add operation is invoked. So it is easy to see that the bit register can perform two increments by 1 events before reaching a state where an overflow happens and the process naturally deadlocks. Let's show this analysis using the model checker. First, I'm going to open the model checker perspective and check if all constructors used in the model are supported. Then we invoke the deadlock analysis and the model checker is working. Now we have the result and the process has a deadlock. To see the real situation of this deadlock, we just perform a double click and the model checker shows the exact trace to find a deadlock. Here, the init operation is executed and initializes the state value with 7, and some internal operations are performed. And here we have an increment and another increment before finding a real situation of deadlock.